Swayam Prabha. Digital India. Educated India.
So, we will just take up some of the questions which were raised. Let us say one of the question was how offset printing produces photographic prints. So, this is very clear that if a photographic print has to be produced, then you should be able to generate large number of shades, very large number of shades, right. So, the minimum thing that we can expect is that it is going to be called a 4-color process, and the plates that have to be made will be one for the yellow, one for the cyan, one for magenta, one for black. So, you will basically separate the colors digitally first, so that you have separation in 4 color scheme, and then make 4 plates and just overlay one or the other. That is the way you can produce. So, 4 different rollers for 4 different colors. So, but basically what you have to do is first segregate. So, that's the way photographic prints are produced. So, it could be inkjet, it could be any other method, but you have to do the same thing. So, this was one question. I have just tried to modify the question in a way that covers 1 or 2 responses from different people. What is the general process of creating a positive design? The question whether it is a roller printing, rotary printing, lithographic printing or any other printing that you think. So, what has to see is finally what is happening. Finally, if suppose there is a thing that finally it is a like a stamp, okay. The stamp is being printed. So, whatever design is to be printed has to be exactly same as to be printed, all right. Or if it is the screen, then you are going to do the screen design in a manner that the color does not flow from the areas which you do not want. So, it based on the technology that you will be generating a positive and negative. Like you make a tracing paper either by hand or by any other process. So, you have to decide which technology you are thinking of. If the technology says that well this is going to be used to produce a design which is going to be positively used for thing, then you will ensure that this particular area, if it is a photoresist, is hardened on the plate. If it was a screen, then you would say the other area should be hardened, and therefore, whether you will make a positive or negative before let us say exposing it to ultraviolet light, your technology will decide whether the tracing is going to be positive and after that what is going to be negative. So, this is although you know what you want to do, but this is what is going to be. For example, if this is a plate for an offset printing and then you have a photoresist coating which has been put on the plate, and then you put a mask. Okay. So, this is a mask. So, you put a mask which could be a tracing paper or whatever, and so light cannot come from some areas and the light can come from some areas. So, wherever the light comes, that portion is going to be hardened. Let us say it is a photoresist and it is sticking, and when you wash it off other portions will go and only this will remain. If this happens to be an offset printing, then this is a oil attracting portion. So, the oily ink will be attracted here, other is aqueous where the ink will not go, will be cleaned. So, this is a, in a way you have made a positive which is going to actually be transferred as it is, as it is. Wherever there is a design, this hardened portion is there. It was a screen printing, then it would be reverse of it. The screen roller would have a reverse of this. This is also a general question which is trying. Structural features of a dispersed dye suitable for sublimation transfer printing. So, basically the question is for the sublimation, and therefore, what can sublime? All right. Sublimation obviously means without melting going directly to vapor, because if melts then we do not know what exactly can happen. Then the transfer of the dye in a molten form will go by the different mechanism. Right or wrong is a different story, good or bad is not the question, but here we are expecting it is going to vaporize. So, there are some type of organic materials, this is also one of the things, this is generally organic. So, organic material which can sublime have to have some of these characteristics. So, if it is a low molecular weight compound, it will help sublimation. If there are more side groups, then it will help sublimation. If there are less polar groups, then again it will help sublimation. So, molecular weight may be responsible, the side groups will be responsible, and less polar groups will also be responsible. That means ionic groups and other things, if they are less, then it will help in sublimation transfer. So, that is approximately the thing. So, it is the same question repeated again, but in a different way. The polar ionic solubilizing groups affect volatility. So, something which sublimes obviously means that the intermolecular forces are weak, and the polar groups, ionic groups and solubilizing groups, which means they love water, they love such kind of things, and therefore, these groups will reduce the volatility. So, higher is the intermolecular forces, lower will be the volatility, and so approximately the answer is similar to what we had said as the suitability of any molecule to be able to sublime. Again similar kind of a question, but specific to inter and intra hydrogen bonding. That is, if you have a molecule where intermolecular hydrogen bonding is possible versus intramolecular hydrogen bonding, or shall we say where the intermolecular hydrogen bonding is less. So, one case the intermolecular hydrogen bonding is more, in the other case let us say the intramolecular hydrogen bonding is more and intermolecular bonding is less or not facilitated. That is the kind of question. So, intramolecular bonding, if it is more, it will help in sublimation transfer, because the molecules will be able to separate out from the solid and get into the vapor phase, and under the standard temperature and pressure conditions, you can expect high vapor pressure. So, we would expect high vapor pressure would mean more relatively higher rate of diffusion also at the temperatures that we are talking about. So, general question again, how dispersed dyes are classified and their suitability to transfer printing. So, this classification is on a groups. This is not that, because every dye molecule is a different molecule. So, you are talking about segments, that is a range, and this range is in some way an arbitrary range. So, you classified them into say, very high energy, very low energy and things like that. So, but approximately roughly this may be that classified into high, medium or low. Some people have classified into A, B, C, D also. So, B and C would come into the medium category approximately, depending upon the temperature required for 90% of development diffusion in a time period of 30 seconds. So, higher is the temperature required, will be higher is the energy of the die. So, 90% if it goes in 30 seconds, then you are quite efficient. Otherwise, every die at almost all temperatures which are higher enough would keep on vaporizing and diffusing. And if you give more time, more diffusion will take place. But then hopefully we are looking at polyester, nylons and so on and so forth. You would not like to keep such material for a very, very high temperature for a very long period, because in oxidative environment everything can happen. So, it is not just a dye transfer. So, this is a standard, but you may still optimize at 45 seconds, that is okay, because you may want more than 95%, that is a fine, but general definitions. So, general thumb rule is a thumb rule, as you already know that generally the molecular weight may be less than 300 for low energy dispersed dyes, right, and sublimation temperatures may be below 150. Now, there will be difficulty of this, because if your ironing temperature also was around the same, then this may also come out. So, those are the things. Medium energy dyes have been classified roughly with a molecular masses between 300 to 400 and sublimation between 150 to 200. You can say this is a very large range. So, this is not something which you say, well, this is it and not. And high energy would definitely have more than 400 and sublimation temperature also more than 210. And so, you are going for higher temperatures. And what it means is, maybe if you want to go for a transfer printing, then maybe the temperature is to be kept maybe 210, 220. And so, you may not like to do that. So, there was another question, what is the practical use for the free mean path concept in disperse transfer printing? Well, people who deal with the molecules, they would like to characterize the behavior of every molecule in any phase that you want to test it out. So, for a practical person who is only optimizing the transfer efficiency of from a paper to a fabric, he or she may optimize by time and temperature. But the people who design molecules and the people who say, well, this is going to behave better than the other one, then they would like to consider this as well. Now, if the molecular size is large in a vapor form, it will collide faster. If molecular size is low, it may go more distance. If molecular size is low, but can go more distance, but can come out also easily. So, the decision whether it is going to be really good sublimation fastness, sublimes less, is also dependent on molecular size. And everything that we are talking about is happening in the vapor phase. In a vapor phase, the transfer is by travelling in the space, and not most of the time, instead of, if it was a solution, then the dye was to travel in the solution. by interacting with almost everything. The moment you say there is a solution, the molecule is interacting with everything. But here when you are a gas, there is a space where the molecule may go without touching anything. And so, you may be able to, if suppose you happen to have a distance between the ink surface and the fabric surface very low, then it may immediately go there. And if this is very large, you have to decide what are you going to do, apply more pressure. If you apply more pressure, some fabrics will tolerate, others may not tolerate. So, this whenever you do a theoretical study, so it is basically characterizing a molecule which would behave, or which how will it behave in the practical thing when actually is going to be used. In this case, because it is going to be finally in the vapor form, so it is behaving like a gas, and so how much possible path is there before it contacts the other molecule. So, related to the size of the molecule, of the dye, and that of any other molecule present in the path. Now, you can appreciate that there will be other molecules also other than dye in the path. It is not a vacuum. So, other molecules are there, it can strike them also. Their molecular weight may be also different. So, theoretically one would be interested in finding out what kind of molecules are there and what are their sizes. In fact, not only that, you may have a mixture of dyes because of which you have made a shade. So, all the dyes which may have a different molecular weight, approximate molecular weight may be same, they are available and they would hit each other, and so mean path which you actually wanted the direction to be always in the direction of the fabric, but in a kinetic energy state at a high temperature in a gas form, the molecule may like to go anywhere. So, if the path is very less, is very good, but the distance or a gap at the molecular level is very high, even that. So, you say we will apply some pressure or apply a vacuum. Vacuum would mean that you are reducing the other molecules which are other than dye maybe. Also, you are creating a direction in which the molecules may travel. Let us say put it this way. What is ideal gas behavior? This also was one of them. So, this is defined by three major properties, which is for the ideal gas. You must believe that there is no ideal gas in general. So, an ideal gas would be that where the molecules are in random motion and they obey the Newton law of motion. If going in a straight line, just keeps going in a straight line unless acted upon by some external force. So, they are random motion. If you put vacuum, if you put anything else, then it is not really random either. You are trying to push them. So, you may create an environment which is not necessarily ideal gas, but it may be in your favor, but that is what you will do. And the volume of the molecules is negligibly small compared to the volume occupied by the gas. That means there is enough space. Fact is, gas is meant to have lot of space. So, volume occupied versus the number of molecules. Number of molecules could be the size of the molecule is small, therefore, it can travel distances. And also, it is expected that each molecule is independent and does not have intermolecular forces. You see, whenever the intermolecular forces become strong, gas becomes a liquid, liquid becomes a solid. Now, you are going the reverse direction, and so at a higher temperature it is expected that the kinetic energy is going to be sufficiently high that any of something called intermolecular forces is not going to be acting. Otherwise, one molecule moves, the other will move along with it because of the interactions. Now, it will only move because it collides. Then it will have elastic collisions, for example. This also could be one of the assumptions, that elastic collisions, the shape of the molecule on a particle does not change, it is just some kind of particle, it just goes like this. So, this is ideal gas behavior. So, we expect that the dye, which are the dispersed dyes after sublimation, are in the vapor flow form and would be closely governed by ideal gas law. But we already know that molecules do have attraction, but the condition is that you are at a higher temperatures. If your kinetic energy is so high that the weak interactive forces do not affect. Another question was, how is vapor pressure correlated with dye concentration? So, I assume that what was meant is, if the vapor pressure is high, does the dye concentration responsible for this? Is the dye concentration responsible for this? So, higher is the concentration of the dye vapor, now vapor form, higher would be the vapor pressure, because the molecule, the pressure is what? Pressure means if there is something called assumed container, the molecules and the kinetic energy, they are going and hitting one or the other, and if they are more in number, they would be obviously having less space and they will be hitting more often statistically, and so more pressure is getting created. So, if higher vapor pressure is recorded or given to you, that means concentration is likely to be higher in that area, all right, something like that. So, there is a gap, there is a paper, there is a fabric and an ink layer, and so in one case you see there are more number of molecules in the gas form, in the other case there are less, and so pressure in one case is going to be less and the pressure, vapor pressure in the other case is going to be more. And how will it affect the dyeing? Obviously, diffusion characteristics are also going to be there. The probability of every such molecule contacting the fiber surface, where once it touches the surface, hopefully because of the affinity reasons, it will then start diffusing inside. So, it is a transfer of a different type. So, one would obviously expect higher rate of diffusion as well.
So, does it depend on the molecular weight also?
It depends on everything that we said. All the properties, the molecular weight, the bulky groups and the polar groups, all of them will decide. So, if the vapor pressure is low of a molecule, then you know this should not be used in mixing to get another shade with another dye. So, all the dyes which you use together to get a shade must have similar vapor pressure development at a same temperature. If that does not happen, then obviously rate of transfer will be different. So, your shades will change, what you expected will not be there, other than the fastness properties. So many of them, but what I say is okay, it is related to the transfer printing anyway, but related to the gas being directed in one way or the other. So, vacuum assisted, nobody would like to create vacuum, it's costly, all right. But like in a scanning electron microscope, in a transmission electron microscope, you create vacuum because you want to remove all other particles from there, all right. Creating a vacuum in almost like a porous substance is difficult, that means costly. But what it means is that you are taking out other molecules which may interact, collide. and you may like to give some type of a direction. For example, if there is one paper here or vacuum is applied on this side. So, chances are that either from the sides or from somewhere else the air is going to be sucked in one direction, and so molecule also is going to go. The air may pass through because it does not have affinity for the fiber, but the die may strike, and so once it strikes, it strikes. So, thickness of the fabric is one reason you may want it, particularly if it is a pile structure like a carpet, rugs, and even non-wovens for that matter. So, if you have such type of material, then the difficulty is that there are more open spaces and you do not have a flat surface, and so in such cases you would require some assistance. So, you have a pile structure, you apply vacuum on this side. So, you expect the direction of all the things to be in this direction more. So, otherwise some of them, because of space, may like to go out as well, because and you can't put so much of a pressure on a pile structure. That is also a difficulty, because if you put at a high temperature good amount of pressure, the amount of pressure that you put it on a flat fabric, you may damage this texture. Fiber may not get damaged, but the texture can get damaged. And so, you would then you are losing the thing. So, you would probably not apply so much of a pressure, and if you do not apply so much of pressure, there are more gaps. If there are more gaps, then you would like to have some mechanism to guide the molecules in some other direction, which is your direction. So, difficulty basically is the cost because of the leak, and so that is the basic difficulty. If you can have that, there is no problem. Other, of course, is that you are also forcing some amount of air from the sides. So, dye does not go outside, everything comes in. It is like creating a vacuum within the system, but you are sucking, it is basically sucking. I think it is also the question that does not look the way, but it still I believe is connected with the sublimation transfer printing. So, what it meant is a pigment also is like a dispersed dye, all right. So, can we use pigment to dispersed dye? As long as it behaves like a dispersed dye. And what is the behavior at the temperatures that you are looking at? It sublimes. A large number of pigments may not be organic, they would have nothing to do with sublimation. Large number of pigment may be metal complexes, organic, organometallic dyes, they may not like to sublime, and so if they do not sublime, then you can't do. And other thing is, generally pigments have no affinity, so normally you require a binder. So, if they had affinity, then they would be dyed, they would be called dyes, then there is no pigment problem. So, they would be called dyes. So, they may not sublime at the temperatures required, at least at the organic pigments, and so you may not be able to do that. Even dispersed dyes do not have affinity for every fiber, that is one. Affinity is important as far as the dye or dyeing, the printing is concerned. This was probably a different kind of a question. I just tried to pick one up. This has a color, this compound has a color, 2-nitrodiphenylamine has a color, but it is still not a right dye. I mean, you would not even use it for dyeing. So, why would you use it for printing, right? So, normally we believe that transfer of dye for printing or dyeing may have a different mechanism, but at the end of the day you would expect that this is going to last the washing cycle, last everything else and so on and so forth. So, it is actually by itself molecule is a very nice molecule, but it is not a dye from the textile purpose. This is the molecule, and for sublimation, well, it melts also. So, sublimation transfer printing obviously by itself, otherwise this is just a molecule which gives some color, very nice color, but very small molecule by itself does not appear to be very nice. So, this is regarding the wet transfer printing of wool, but even if you do not do any transfer printing, Lenasol dyes are good for wool, specifically designed for wool and silk. And so, the reaction mechanism obviously depends more on the with the amino end groups. So, wool and silk have end amino groups, a large number of them. Acid dyes also do the same thing. So, Lenasol reactive dyes, okay, we are talking about. So, a suggested mechanism could be something like this. So, you have a dye which obviously has a possibility of reacting anywhere, let us say. Even water also at certain temperatures you can expect one of the bromine goes off, possible. And so, you create some groups which are ready to react, right. So, when the dye is in this form, which is this form, then it can react in two ways with the wool or amino acids. One, that it can react and make a compound of this type and this portion still remains free, and the other could be this. So, both are different type of reactions, because in one the carbon has a possibility of free two bonds and therefore, it is more reactive. So, it goes there and makes some kind of a addition reaction. It was basically a bromine. So, there was a CHBr. So, one is showing that there is a possibility of H and there is a Br was gone. So, there are 2 points which are available, which are reactive sites, and so one can become CH2. In this case, the H may be here and this other is N, which is from the wool which has come, and the H of the NH2 also is here, H. So, that is one. So, there are two ways of doing the reaction, and then this compound also can go further and react and make both of them finally would be more comfortable making a group which is a aziridine. Whether you come from there or you come from the other side, you will still be able to form this type of a group, which itself is a reactive group. This is a reactive group, 3 membered rings. So, this ring can break, and if this ring breaks, then there is another possibility that this ring can combine with another wool molecule, but depending upon where the amino end group is, obviously steric hindrances will always come into picture. So, it can break and make another group which is NH and CH2 or OH and things like that, but this also is possible. So, either one molecule with one dye or 2 molecules groups with one dye may react. So, which one will be first, which is second is not so important. So, this is how approximately reactions can take place. Now, this is another question which is related to this. Can we use Lenasol reactive dyes for wet transfer printing of cotton, because it has come from being used as wet transfer printing of wool. Idea is that wool, it was developed for wool because wool was not, doesn't get much time in transfer printing, and so you needed something which can very easily react with the amino groups. And this particular thing was designed in a manner that it would be reactive enough in the acidic medium. Should be that's the way it was looked at. And it will be more stable also in acidic medium. Otherwise, with water, temperature and alkali, both the groups would immediately get converted to something else if it is alkaline medium. So, they work in the acidic pH where they are able to react with amino end groups. Okay. So, theoretically it can happen, but it is an alkaline condition. The chances of dye remaining reactive are going to be less, efficiency is going to be less. So, we have other reactive dyes which can be used, because cotton would require alkaline conditions to make it C cell O minus type of a situation. And so, you require alkaline conditions. So, theoretically yes, why not, but the chances of, it is like for example, you do not use dichlorotriazine because it would react too fast and have more wastage. So, here also the two bromines, they will immediately react here and there. So, acidic reactivity being controlled, wool is readily available around the time, and so amino acid groups can react. So, I do not think it is a good idea to use them, but something you will get definitely. Question which is just been modified in a way that triaryl methane type of dyes. They are brilliant, give good color when in ionic form, other than that they, because they become cationic, so certain fibers are preferred. That is one part. But if we look at a dye which is the first structure and versus the second structure, so you can see that if cations are not there in any condition, then the conjugation is also not very good. So, the moment you create conditions where cation is created, so you can appreciate that from here to here the conjugation is there, and there is a resonance possible that this particular nitrogen can also have a double bond like this and get a plus charge, and this one. So, two structures alternatively are possible. So, they have better resonance and also better conjugation, and so whenever such situations will be created, obviously deeper, better, brighter colors are going to be produced. So, we have seen, I have given you probably an example of a phenolphthalein also. If it is not ionic, then it is a colorless material. So, if you want color, you go to the ionic state. So, it does not matter which type of a thing you can have, you create a condition where ion is going to be created. Should one print polyester acrylic blended fabrics by sublimation transfer printing method? So, first of all, these two fabrics, two fibers, from thermal stability point of view are very different in character. Polyester, you can take it to 220 degrees centigrades and also feel good about it, and a lot of things can happen. Acrylics at higher temperatures start getting yellow. So, thermal stability is always an issue, and if you do sublimation transfer, that means you obviously have to have some high temperatures. So, what are you compromising? Either temperatures are going to be low. If temperatures are going to be low, maybe transfer to polyester may not be that good. If temperature is high, acrylic may suffer. So, it would be better that we go by the different printing route than the sublimation. You can always print polyester acrylic using the normal printing techniques, all right. Sublimation may not be the best method. So, I said acrylics are sensitive to thermal treatments. One can choose lower temperature for transfer. Polyester requires higher temperature, so generally not a good idea. But if you still believe that you need to do it, low energy dispersed dyes could be used, which can dye both of them, and but wash fastness may not be so much of a problem, but sublimation fastness would be an issue. So, this was something on the release paper, very specific question, which was you had chrome based stearic acid etc. being used. So, stearic acid by itself is a hydrophobic material. So, hydrophobic printing etc. could be done very easily compared to oil based system, and then release can be done. So, it was only a coating on a paper. That is the question which is there, why do you use that? So, chrome complexes of myristic and stearic acid have been used, and they are cationic because of the chromium, and so positively charged moiety is attracted towards generally negatively charged paper surface. Almost everything that we see here, chances are that it is more negative, and so when you coat, instead of going away, it would have some tendency to be there. So, you can coat easily, but it is not a very high energy bond or something, but it is still there. So, you can easily coat, so it can released also. But interestingly, the molecule in some sense becomes oriented. It is like you have surface active agents, hydrophilic versus hydrophobic. So, something which goes in one direction, the other goes in the other direction. So, the hydrophobic moiety may be pointing away from the surface of the paper. This makes printing of this easy. It is against, for example, if somebody had a nice paper, you coat a silicone on this and try to print. The release can be good, but even coating is difficult. You see, normally what happens is that when you have those stickers which you remove and put somewhere else, so they may be based on thing that mild sticking takes place, but you want to remove it, should be able to be removed. So, that is one respect. So, there is a milder kind of a arrangement at the paper film surface and hydrophobic moiety on the outside because of just some orientation automatically occurs. And so, easy printing of any technology, any technique that you can use, method, and print, and then of course, later on maybe it will be easy to remove also. So, I think these were some of the questions that I have taken from your responses. So, hopefully it will help you. See you later.